And get started. Hello, everyone, and welcome to another Applying Ethology webinar. I am Laura Whalen, and together with Jenyan Shao, Christian Nauroff, and Sebastian Gaman, we organize these webinars in the Animal Welfare Slack workspace. As we begin today, I want to remind you all to please turn off your camera and microphone. Should you have questions for our speaker, please type them into the chat box, and we will address them at the end of the presentation. It is my pleasure to introduce Serge Alindekon from Rostock University. Serge is interested in enhancing animal welfare and management through technology. Today, he will share new automated behavior annotation methods based on pattern recognition associated with unique identifiers in chickens. Welcome. The floor is yours.
Thank you, Laura, and thank you, Christian, for giving me this opportunity. Hello, everyone, and thank you for joining this webinar. My name is Serge Alindekon. Today, I will present an automated method to validate animal tracking technologies for ethological purposes. So this method involves pattern recognition and unique identifiers using chicken as a model. This research is primarily a methodological contribution rather than an advancement of knowledge. The method was developed to facilitate my own data collection for my PhD research. Okay. Among tracking technologies used to monitor the presence of chickens around functional resources such as feeders, you will find RFID and computer vision system, which are very popular in study on poultry behavior. These technologies are progressively being adopted because they allowed remote, in situ, non-invasive, longitudinal, and individual-based tracking. Additionally, they make the study of animal behavior easier. You will agree with me that validation, that is ensuring that the technology is indeed measuring what it's supposed to measure, is a crucial step before adoption. Typically, we benchmark the measurement against human observation, which is commonly accepted as the gold standard in the field. But the problem is that this crucial step is often overlooked, and this is understandable as manually annotating video is time-intensive, labor-intensive, and resource-consuming. So it is no surprise that only half of the studies involving RFID in poultry have performed this validation. So to overcome this difficulty, we propose a method for automated annotation of animal presence within given area. The idea is to use this method to benchmark other tracking technologies to replace or complement human efforts. The automated annotation method includes two main steps. The first involves the use of markers called ARUCO and making them 3D. ARUCO markers are simplified open source QR code-like markers, each associated with a unique numeric identifier. We assign the marker to each chicken, fold it to form a cube, and then attach that 3D obtained cube to chicken vest. And with our marker reading program, we can detect these IDs in the video. I will show you in a moment how it works. The second step involves defining region of interest, which for us in this case is the functional area of the feeder. This step involves marking and outlining the region where most of the animal stands while effectively using the feeders, and then blurring out non-relevant area, as you can see in the third picture. The automated annotation method yield two outputs. One is annotated videos. I will play the video for you in a moment. Yes. As you can see, the IDs of the animal are automatically shown from the moment they enter and throughout their presence within the region of interest. Since we have 3D markers, we can identify the chickens from almost every direction. And knowing the frame rate, we can determine how long each chicken appear in the video, so appear in the region of interest. Now the question is, the second output from this automated way of tracking is a CSV file with presence data, including timestamp for the start and the end of each visit. Note that so far, I've been mentioning visits and presence within the region of interest, not resource use, because this automated annotation can only track chicken presence within a region of interest and not necessarily the effective use of the resource. It's important to make a clear distinction between mere resource use and presence within a region of interest. So now the question is, how valid and reliable are these automated annotations? The comparison between automated annotation and human annotation showed a 98% correlation. And in addition, the classic performance metric like accuracy, sensitivity, precision, all exceeded 98%. These indicate very good performance. The automated annotation method is valid and reliable. And besides the good performance, the automated annotation enable about 85% time saving, of course, given the performance of the computer we use. And most interestingly for me, without straining my eyes, my neck, and back. It is an efficient method. Here is the take-home message from my presentation. A 3D marker solution is proposed for the automated annotation of chicken presence around feeders. And this method offers visual ID-based tracking with timestamps for precise analysis. It's achieved 98% validation performance and saved about 85% of human time. And so that is why we believe that it could be used to facilitate the validation of new technological tools for ecological purposes. With this, I would like to thank you for your attention. Your question, comment, and suggestion are welcome.
Thank you, Serge, for your really nice presentation. It's always good to have videos and see what you mean by this 3D identification. Having watched many videos myself, I really look forward to a day when we can just import the videos into a system and have them watched. And it looks like you've managed to find a very good way to watch the videos when the animals are in a specific behavior or a specific location. But have you seen any work about animals doing more nuanced behaviors? Like, let's say the chicken is scratching their face, for example. Have you seen any work to try to get at behaviors, not just location?
You mean if the vest and the what they have in the back affect their behavior? Is it what you mean?
So you've managed to use these ID markers to say that the chickens are at the feeder. And so
Yes.
then you can use that as a proxy to say they spent this much time performing a feeding behavior. But let's say, like in that video, you had some of the chickens were eating, but one chicken was standing by themselves and they were not eating. So have you seen any work that's able to pick up on the behaviors the animals are doing, not just the location? So for example, have you seen any work where it marks that these chickens are eating, this chicken is next to the feeder, but not eating?
This tracking method cannot be used to infer the effective use of the resources. In the literature, you will see people using other tracking method to record the effective use of the resources. Either the chicken is just there, not doing anything, eating or passing by, it will be recorded as presence. So to answer your question, these tools cannot be used to monitor the effective use of any resources, at least the feeder. But it will require the use of additional tools for that purpose. Maybe key intelligence AI tools to complement this one for that purpose. Here we just want to see if the animal is in the functional area. That means the importance, the area where animals stand when they want to use the resources, because classic technological tool like RFID usually only pick the signal of animal in the proximity of a given area or in the proximity of the resources. It won't give you that information if the animal is effectively using the resources or not. So that's why we focus on the validation of those tools coming just in the proximity of the resources.
Great, thank you for clarifying. Do you have any next steps you're dreaming of? That's this part of your PhD, right? So do you have any questions that you're hoping to ask with this technology?
Yes, of course. I am actually using RFID in my study and computer vision tools, and staying, behind screen, scoring videos and validating those tools is really time consuming. And that's why I developed this tool actually. And right now I'm using it to validate my RFID system I have in my barn to replace human, because we know that it's really reliable. It has about 98% accuracy or performance, so to say. So yeah, I'm already using it actually. I'm already using it.
Very cool. Do you see any application? So for example, if you gave this talk to farmers, where would you suggest, if they had enough money for one camera RFID or a similar system to what you've developed, where would you suggest that they put it? What would be the most applicable question that you think we could use this technology for going in the future?
It's important to indicate that this technology, like tracking with the Aruko markers or QR code like markers like this, is for ecological purposes. A farmer, it's not possible for a farmer to have these, assuming you have thousands of chickens. That's not possible, but just for a validation purpose, which is usually short duration, because to do the validation, you need few days and maybe few animals, like 20 animals, for instance, 5 days of recording, things like that. You can use this. But in commercial setting, it's not possible. It's not possible. Maybe the RFID, because you have tag now that are very light, and it's very cheap, not expensive at all. My tag cost less than €1, something like that. And so maybe the RFID can be used in commercial setting in pig and cows, you already see people using RFID for a very long time. Maybe in chicken, but one thing is sure, camera, computer vision tools can be used to track animal, and you will see that in commercial setting already.
Okay, great. I don't see any questions coming in, so there is one. From Katie, thank you for the presentation. It is a super cool tool. I was wondering if you noticed any effects of wearing the tags on the chicken's behavior. That is, do they peck each other's tags?
Thank you for that question. I was expecting that question. The first day when we place the vest, we observe some behavior like curiosity stuff. Some were trying to remove it. But after a few hours, about 2 hours, they start forgetting the rest and then focusing on the daily activities, feeding, drinking, perching normally. The next day, no animal at all was focusing on the behavior. On the rest, they consider it normal. And to make sure that it's not really affecting the animal, we had our animal officer following the animals continuously, but we noticed that after that first day, so I would say few hours, the animal completely accepted the rest like in your reverse and continue. And as you can see in those pictures, you see this is already day 2. You can see the animal are fine with the vest. So no major change in the behavior. Pecking, no at all. I won't argue that this vest is kind of preventing further pecking. I won't say that, but it's something like that we also observe. Because the chicken we have, sometimes they already develop some pecking behavior, and even with the vest, no, it's not that even possible. But the animal use the vest for short time, maximum 24 hours. We remove the vest. Next day we use it again. We place the vest back to them. To place it, it's simple. We just put it by the head like this, and it has some Velcro. Is it Velcro?
Yeah.
Something like that to fasten the vest, and it removed quickly. And those vests are commercial vests. You can buy them. It's actually commercial vests we use to adapt. Already known, it's called visibility vest or something like that, used to prevent animal for road accident, something like that. Yes.
Great. Thank you very much, Serge, and thank you, Katie, for the question. I don't see any further questions, so thank you very much for taking the time to share your latest research with us. I'm looking forward to hearing how your PhD develops.
Thank you.
Thank you all, and yes, see you at the next one.